Now next question. 4 identical charges are placed at the corner of a square of side A. Find the resultant force. So this is a diagram. We are having a square, corners A, B, C, D, and identical charge Q, Q, Q placed at each corner, and the side of square is A. Okay, now you are asked to find out the resultant charge. So here also I am taking A as a reference corner and trying to find out the force acting on A due to D, due to C, and due to B. So extra there are 3 charges. So your K value will be 1, 2, 3. So you know the magnitude of charge at each corner. Now you have to find out the position vector. So I am going to first write down the coordinates. Here this A, x coordinate is A and y coordinate is also A. D, the x coordinate will be 0 and y coordinate will be A, right? And here C is 0, 0, and B, the x coordinate will be A and y coordinate will be 0. Now you can write the position vector. Here it is 0 AX, 0 AY, here A AX, 0 AY, here A AX, A AY, here 0 AX, A AY. Now solution at point A, you are having K value 1, 2, 3. The position vector R at A is AAX plus AAY, this one. Now the position vector R1 at B is AAX plus 0 AY. Position vector R2 at C is 0x, 0 AY. R3 at D is 0x plus AAY. Now you can find R minus R1, R minus R2, R minus R3, and similarly you can find out the magnitude also. Magnitude of R minus R1 will give you what? Square root of A square, that is A. Here what is the magnitude of R minus R2? It is the square root of A square plus A square, that is root 2A. And here the magnitude of R minus R3 is square root of A square, that is A. Then you can write the expression for Coulomb's law. F is equal to Q by 4 pi epsilon sigma K equal to 1 to 3 Qk R minus Rk by magnitude of R minus Rk, the whole cube, and this Q is my Q at point A, and this Qk is my Q at B, C, and D. Finally you can sum it. That much of Newton will be the answer. Try to find out the final expression for F. Okay. Next is calculate the electric field intensity at 1, minus 2, 3 due to point charge minus 4 microcoulomb kept at origin. Assume epsilon R is equal to 1. So you know what is the relation connecting electric field intensity and force? E is equal to force per unit charge. So the expression is something like this: 1 by 4 pi epsilon 0 sigma K equal to 1 to n Qk by R minus Rk, the whole square, magnitude. This Qk will be this one. Okay, so I can rewrite the expression as E is equal to 1 by 4 pi epsilon 0 Q1 by magnitude of R minus R1, the whole square. You know 1 by 4 pi epsilon is 9 into 10 raised to 9, and Q is minus 4 into 10 raised to minus 6, and R minus Rk, what is R? R is 4 microcoulomb, which is kept at the origin. So that R is equal to 0, the coordinate is 0, 0, 0, and R1 is this position vector, that is AX minus 2AY plus 3AZ, that is your R1. So take R minus R1 and find the magnitude. So you will get square root of 1 plus 2 square plus 3 square, that is the magnitude of what? R minus R1, and then that magnitude, the whole square, is the expression, that is this square. So finally you will get 2571 Newton per coulomb. The unit of electric field intensity is Newton per coulomb. Now the last question is, three positive charge Q, 2Q, 3Q are placed at the corners of an equilateral triangle. If the length of each side of the triangle is D, find the magnitude of electric field intensity at the point bisecting the line Q and 2Q. So this is that point, bisecting the line Q and 2Q. This problem is similar to the one which we did earlier, the second question. So electric field intensity is F by Q. So your expression is 1 by 4,500 sigma k equal to 1 to n qk r minus rk. Here totally we are having three charges, A, B, C. Okay, so here the k value is 1, 2, 3, and this qk will be this q, and this q. So I am 1, that is equal to 1 by 4,500 sigma k equal to 1 to 3 qk by r minus r2. Next, what you have to find out, the question is, you have to find the magnitude of electric field intensity at the point bisecting the line between q and 2q. So you have to find the electric field intensity at this point due to A, B and C. So what you have to find is, next you have to find the position vector of A, B, C with respect to point P. Okay, that you have already can find out what is this one. This at this point the coordinate will be what, 0, 0, and this point it will be, what is it, D, 0, right? And at this point it will be what, D by 2 root 3 by 2D, the same thing what we did here, this one here. In this expression it was given all the charges were identical, but in the last question it is given that you are having three different charges and the distance and the length of each side is D in our last question. That's the only difference, and you are asked to find out the electric field intensity, not the force. Okay, so you can proceed it. What you have to do is that is 1 by 4 pi epsilon 0 into the, this is a common factor, so that I am taking outside, then the main bracket q1 by r minus r1. So what is r? R is the position vector of P. R will be the position vector of P and rk will be the position vector of A, B and C. So what will be the position vector of P? P is exactly at the middle of B and C. So the coordinates of P will be what? D by 2, 0, right? X axis is D by 2 and y axis is 0. So the position vector is D by 2 AX plus 0 AX. So here you can substitute D by 2 AX plus 0 AY minus R1. R1, if you are taking this as R1, then you write the position vector of R1 minus it, take the magnitude, then square it, plus Q2. What is Q2? Q2 can be this one, BQ. So you can write small q divided by R minus R2. What is R? You know, the position vector of P. And what is R2? The position vector of B is 0, 0. So take the difference, take the magnitude and then square it, plus Q3 by R minus R3 the whole square. What is Q3? This one. Q3 is 2Q divided by R minus R3. What is R? R is AX, sorry, D by 2 AX plus 0 AY. And what is R3? R3 is DAX plus 0 AY. So take the difference, take the magnitude and then square it. Then finally sum the 3 and you will get the answer. That measure Newton per coulomb.